Greetings all, I am Aishwarya from final year ECE.
And I'm Preetika from final year ECE. And now we are going to present our project on profiling of comestibles for authentication and detection of adulterants.
Nowadays, the food we consumed are more susceptible to adulteration and put many health disorders to the consumers. Our research focuses on liquid food, notably honey. For detecting the adulteration in the honey, we go for two approaches, namely spectroscopic approach and acoustic approach. This is our post block diagram. First block will be the spectroscopic approach. Second block will be the acoustic based approach. This is a spectrophotometer used for the spectroscopic based approach. In the spectrometer, we obtain two parameters such as absorbance and transmittance. For this, we need to prepare a sample of different concentration with diluted with distilled water. This absorbance value is taken from the spectrophotometer. From this value, we infer that the increase in concentration there will be a more absorbance for the honey. The transmittance result obtained from the spectrophotometer. For this, inversely proportional to the absorbance. This is a UV visible spectrophotometer, also used for the spectroscopic based approach. For this UV visible spectrophotometer, we need to prepare a sample. That samples are diluted in the ratio of 1:20, that is 4 gram of honey in 100 ml of distilled water. This is a spectrum obtained for pure honey.
After getting the samples for pure honey, we add adulterants such as molasses, glucose, and sugar syrup in various concentrations. And for that, we obtained a spectrum for wavelength versus absorbance. And here we can distinguish pure honey with adulterants. And this is a spectrum for glucose and similarly for molasses. And all the data collected are given into machine learning algorithm known as support vector machine, which is a classification algorithm. Totally 90 data were collected. Out of that, 30 were pure and 60 were adulterated. And the data split up will be 30% will be taken for testing and 70% for training. And the results obtained from SVM showed that 20 are adulterated and 7 are pure, and from this we got accuracy as 100%, and the cross validation accuracy we got is 98.8% within the testing data. And after that, we have extracted the moment features from the spectrum obtained from the UV visible spectrophotometer. And the moment features were mean, median, and more. Of that, we have set 0.3 as a threshold value in manually, and we inferred that values greater than 0.3 are pure and less than 0.3 are adulterated. And the accuracy obtained from this is 93.3%. And another approach was also adopted, namely acoustics based approach. And here is the acoustic setup we have used. And acoustics and various tones were generated and taken using the digital oscilloscope, and the output of that signal was taken using fast Fourier transform, and these are the spectrum obtained at different tones. This is for 100 Hz and similarly for 1000 Hz and 10,000 Hz. From this we can clearly differentiate that pure honey has a single peak and adulterated honey has two to multiple peaks. And another approach was also adapted for differentiating the adulterated and the pure honey, and using sound level meter. This meter records the sound in decibel. And this is the results for sound level meter. Here the absorbance of the sound level of the honey is more for pure than the adulterated. Thank you. This is the setup we have used for detecting the adulterants. Here we have generated sound using this online tone generator and passed it in a speaker, which is traveled through the sample placed in the paper cup, which is enclosed in a plastic amplifier. The output of the sound is taken using the condenser microphone, and the output will be recorded by the ambulance when using the oscilloscope, which is used for processing.